So what if I told you that the AI revolution is actually making your old video games more valuable? It sounds kind of strange, I know, but we're about to unpack a hidden economic shockwave. It's called Ramageddon, and you'll see how it's affecting everything from your game console all the way up to national energy policy.
It all kicks off with this weird puzzle, right? I mean, technology is supposed to get cheaper over time, not more expensive. But if you can understand why a used PlayStation is selling for a premium today, well, you've just found the key to a much, much bigger story about supply, demand, and the secret costs of artificial intelligence.
So what is this crisis? Ramageddon isn't just some catchy name we made up. It's a very real market shockwave, and it's having real effects on how much we all pay for the tech we use every single day. Remember during the pandemic when used cars were suddenly selling for more than new ones because of that chip shortage? Well, we're seeing that exact same bizarre economic thing happen right here. A 6-year-old console gaining $100 in value? That's a huge red flag that a critical part inside of it has become incredibly rare and super expensive.
So here's the crucial point. The AI industry is like a giant vacuum cleaner, just sucking up the world's supply of memory chips. This incredible hunger for chips is squeezing the supply for everything else. Our PCs, our gaming consoles, and it is sending prices through the roof.
And this chart just spells it out perfectly. After all those pandemic shortages finally calmed down, the price for a gigabyte of RAM fell to just over $3. But today, it's $12.50. That's a 4-fold increase. I mean, that is a direct result of this new, just insane level of demand.
Okay, so where in the world is all this demand coming from? The answer, as you might guess, lies in the explosive growth of AI data centers and the just mind-boggling amount of memory they eat up. Take a look at this number. This is roughly how many AI data centers are in the US today. Now get this. Back in 2016, that number was 0, a big fat 0. We've gone from nothing to over 5,000 of these memory-hungry buildings in less than a decade.
This one statistic it's just staggering. 70%. Let that sink in. That means the vast majority of a critical global component, the DRAM we all rely on for our computers and phones, is going to be funneled into powering AI. That leaves a very, very small slice of the pie for everyone and everything else.
Now, this slide is super interesting because it shows the strategy behind all this. Manufacturers aren't just selling to a new customer, they're changing their entire business. See, AI uses this special stacked chip called HBM. Yeah, it takes longer to make, but the profits are just immense. For a company making these, selling one HBM module to an AI firm is like selling 15 or 20 of the regular memory sticks to us. I mean, the choice for them is a no-brainer.
And here's why that shift is so powerful. The global RAM market is basically a 3-company town. Just 3 companies: Samsung, SK Hynix, and Micron. They control about 95% of the whole thing. So when they all decide to pivot away from us and towards the high-profit AI chips, we, the regular consumers, are left with the scraps.
So we've seen the pressure building up, right? But then one single event came along and just poured gasoline on the fire. And it wasn't a natural disaster or some factory problem. It was something way stranger, a ghost order that sent the entire market into a complete panic.
Okay, picture this. The head of OpenAI sends these letters to the 2 biggest chip makers in the world. And he basically says he wants to buy up nearly half of all the chips they plan to make in the future. The crazy part? He allegedly told each company separately, so neither one knew the other got the same gigantic, non-binding order. This one move created this illusion of just catastrophic scarcity.
And the shockwave was immediate. I mean, in just a few months, consumer RAM prices shot up 171%. Then, the market found out the orders weren't real contracts at all. This shows you something so important. In a market this tight, perception becomes reality. The psychology of the market, driven by one guy's uncommitted move, can cause as much chaos as a real physical shortage.
So, just as the market is absolutely reeling from this hardware crisis, a breakthrough comes from a completely different direction, and it changed the entire game, almost overnight. This number is just incredible. 600%. That represents a 600% reduction in how much memory AI needs. And it didn't come from a new factory or some new kind of chip. Nope, it came from a piece of software.
Okay, so here's what happened. Google developed this amazing compression algorithm they called TurboQuant. It basically lets these huge AI models run using way, way less memory. And this is the key part, with no loss in performance. It was an instant efficiency win, and it proved that Ramageddon wasn't some permanent shortage of stuff.
It was a temporary market shock that could be beaten by smarter software, not just by building more hardware.
So, with the chip crisis starting to ease up thanks to some clever software, policymakers now have to stare down an even bigger, more fundamental problem that's right on the horizon.
You see, the next big bottleneck for AI isn't silicon, it's the electrical grid. There are plans for 1,500 more of these data centers, but communities everywhere, from Missouri to Maine, are starting to say, whoa, pump the brakes. They're worried about what these power-hungry monsters will do to their local grids and, of course, their own electricity bills.
And when a tech giant like Microsoft just comes out and says something like this, it really tells you the scale of the problem. When companies that build billion-dollar facilities start saying the answer is nuclear power, it signals a massive shift in the conversation. The demand is so huge that our regular power sources just might not be enough.
This right here is the new front line for policymakers. How do you balance this incredible push for new technology with energy security and making sure things are still affordable for regular people? Can our aging grid even handle this massive new demand without passing the costs on to all of us? And as we're debating all this, we have to remember this is also about global competition. Our competitors, like China, are already going full steam ahead, building nuclear plants specifically to win the AI race. The choices we make now are going to have huge consequences for our economy and our place in the world for years to come. So that leaves us with this final critical question. The silicon bottleneck, it was bypassed by clever software. But you can't code your way around the laws of physics. The need for raw physical electricity is absolute. So, as we move forward, the nations that figure out how to solve this energy puzzle, well, they're going to be the ones who lead the next stage of the AI revolution.